Okay, here we go. A story of two sequences. This is day one as we're studying sequences and series, and it also matches up with section 8.2 in your book. All right, so let's look at these two sequences. They look very similar. They look like they have a pattern. And so let's look at them a little bit closer and make some observations. Obviously, they are all numbers but separated by commas. They both start with the number 1. But when we look a little closer, this one, as we're looking from number to number, increases by 3, right? Each term goes up by a value of 3. And this sequence, as we're looking for any pattern, we're like, okay, it goes up by 1, goes up by 2, goes up by 4, goes up by 8. So it's not increasing by a constant value. Instead, it's being multiplied by a constant value, right? 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So this is being multiplied by 2. So they both have patterns, but this first one is the pattern represents a linear pattern, while the second one represents an exponential pattern. And I start here just to remind you that we've been working all our math careers on numbers and patterns. And so this sequences and series stuff is actually just summarizing things we already have observed, and we're going to put them together and make them formal by calling them sequences and series. So what do we notice? Let's go ahead and look at the linear sequence. And I know that when I look at a set of numbers, I want to study the pattern by putting them in a table, an XY table. And so I noticed that number 1 is my first term, number 4 is my second term, 7 is my third term, 10 is my fourth term, and so on and so forth. So I'm keeping track of this pattern through a table. And I noticed that, just like we talked about in the last slide, if I do the hoops, 15 minus 13 is 2. Oh, wow. Okay, this is going to be, hopefully, let's change this. That 15 should not be a 15. And probably in class, we noticed that a lot quicker than I just noticed it. Let's make that a 16 so that our pattern can work. So when we have 16, and we do the hoops, 16 minus 13 is 3, and 13 minus 10 is 3, etc., etc. And of course, on this side, my x's are just increasing by 1. And so we know the slope is the change in y's over the change in x. So we notice that our slope is 3. The cool thing about looking at a table is that if we keep up this pattern of the hoops of as we move up the table, we're subtracting 3. As we move down the table, we're adding 3. Well, we can keep moving up the table, subtract 3, right? 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is negative 2, which gives me my zeroth term, which is just my y-intercept, right? When x is 0, y is negative 2. That's my y-intercept, and I can put together the linear equation that matches this set of numbers, right? If I want to know the second number, I would put 2 in there, and I'd get 6 minus 2 is 4. So we already know how to do that. All we need to do today is make it more formal. So instead of using y equals mx plus b like we have been when we describe a set of numbers that have a linear pattern, we're going to use a sub n equals dn plus c. But they match up, right? So here's why we're going to use this. So let's go ahead and, what do we have here? We had 3x minus 2. So we're going to rearrange it as a sub n equals 3n minus 2. Okay. Now here we see a c. I normally write this as a sub 0. I'm not sure why the c is here. So the way I like to write this equation is a sub n equals dn plus a sub 0. And it's easier to see that the reason why we write it like this for sequences is, wonder if we want to know, hey, what's my 1, 2, 3, 4, fifth term? We would write a sub 5 equals, and then we would find out, and we would know that whatever is on the right side matches up with our fifth term. This is very similar, actually, when you think about it. Instead of using y, of using f of x, I think a sub n is a similar concept as f of x, so that you know what you're dealing with. All right, so we already are familiar with linear patterns. We know how to write the equation given some linear data points, and now we're just going to use, instead of y equals mx plus b, we're going to use a sub n equals dn plus a sub 0, with all of them meaning the same thing. The d is actually called the common difference. It's the same thing as the slope. What's going on as we move from term to term? D is your slope, and C, or a sub 0, is the same thing as your y-intercept. A sub 0 is, hey, what's the value in your sequence when you're looking at the 0th term, right? The term that's right before the first term. All right, so let's go ahead and look at this. So find a sub n given. So the first thing we want to know is the common difference. So that's the same thing as the slope. We're just going to go ahead and do our hoops. And we notice that we're increasing by 5 each time. So we know our d is 5, right? And we know that our formula starts with a sub n. So we know d is 5, so we have 5n. And now we need to know our a sub 0. And so we could either set up a table, right? We could look at it, a table like this. And as we're moving forward, we are adding 5. As we're moving down the table, we're adding 5. As we're moving up the table, we're subtracting 5. So 4 minus 5 is negative 1, right? So my 0th term is minus 1. You could also do this just looking at your sequence. You don't have to turn to a table. You can realize that as you're moving forward, you're adding 5. As you're moving backwards, you're subtracting 5. So if we move backwards one more time, we get that negative 1. So this is called the nth term definition, and it describes the pattern that's going on in our sequence. If we look at the next one, we're going to do the same thing. We can either put it in table form or just look at this and do the hoops right on the sequence itself. So as we're moving forward, right, we're adding 3. So we know that our common difference, if we're adding 3, really, Miss Appleby? As we're moving forward, we are subtracting 3. Okay, so we know our common difference is negative 3, just like our slope would be negative 3 if we wanted to write it in y equals mx plus b form. So we could go ahead and turn to the table and say my first term is 12, my second term is 9, and I know that when I move down the table, I'm subtracting 3, but when I move up the table, I'm adding 3. So my 0th term is 15. So my a sub n is 15. Once again, you could do that moving this way. You could, if you know you're going to the right of the sequence and you're subtracting 3, you're doing the opposite as you go to the left. And that's how we would get 15 as my a sub 0. And put it together, we're going to have a sub n equals, so I write a sub n equals 15. I meant to write a sub 0. So we would have a sub n equals negative 3n plus 15. This would be how we would define the given sequence. Okay, let's see. The other thing is that I wanted to talk about, we've been saying linear, linear, linear. Well, when you see a linear sequence, it's referred to as an arithmetic sequence. So that's something that I probably said in class from the very beginning. But just note that these linear sequences are referred to as arithmetic sequences. All right, so let's look at number 3. And it says, given a sub n equals 3n minus 7, find a sub 10. And so what we're going to do is this. We notice that our definition has this n, and the n stands for the term number. So if I want to find my 10th term, I simply say, okay, every time I see an n in this equation, I'm going to plug in a 10. And so when I do that, right, I get that the 10th term is equal to 30 minus 7, which is, well, I should write it, a sub 10 is equal to 23. So the nth term definition is pretty cool. We can use it to define a sequence, and we can also use it to find a certain term. All right, so find the 20th term in this sequence. We could go ahead. It looks like we are subtracting 3 as we move to the right of the sequence. We could just keep subtracting 3 until we got to the 20th sequence, or I'm sorry, the 20th term. But what if it's at the 120th term? We don't want to do that. We don't want to keep doing that. We're probably going to make a mistake. And it's going to be time consuming. Life's too short. So what we're going to do is this. We're going to define it. We're going to note that as we're moving down the sequence, or rather to the right of the sequence, up the sequence, we are subtracting 3. So we know that D is our -3. And that means that if this is the first term, the second term, the third term, the fourth term, if we move backwards going this way, we appear to be adding 3. So to get to the 0th term, that's going to be 15. So my a sub 0, my 0th term, is 15. So we're going to put that together, and here's the nth term definition, right? And now it's asking us to find the 20th term. So that means a sub 20, that means the 20th term is, drum roll, it's going to be what? -60 plus 15 is going to give us a -45. So far we've used our info to write the definition, write the nth term definition of a sequence, and we used it to find certain term numbers. All right, so now wonder if we're given a problem where we're given a term and the common difference, and we're asked to define the sequence, or find the formula, another way to say define the sequence. So what we're going to do is, well, we already know if we started our sequence, our nth term definition of the sequence, we'd have a sub n equals 2n. So all we need is what's a sub 0. So once again, I can look at my table. A lot of people seem to understand this best using a table. My first term is 5. If I moved, and since my D is 2, if I move down the table, that means my second term would be 7, my third term would be 9, and that's nice and everything, but I need to move up the table so that I can find what my a sub 0 is. So if I'm moving down the table and I'm adding 2, if I move back up the table, I'm subtracting 2. And so 5 minus 2 is 3, so that means a sub 0 is 3. And that completes our definition. So this is the nth term definition that works when my first term is 5 and my D is 2. All right, let's look at the next one. Okay, this one we're given 2 pieces of information and asked once again to find our nth term definition. We could do it using table, and that would take a long time, but I'm going to go ahead and do that real quickly so that at least you have this idea in your head that you can always turn to tables. All right, if I'm looking at the 5th term, so let's put 1, 2, 3, 4. I'm going to run out of room, aren't I? The 5th term is 190. Okay, bad idea, Miss Sophie. Let me go ahead and move over here where I have room. So I'm going to do this big table where I have 1, 2, 3, 4, 5. I know the 5th term is 190, and then 6, 7, 8, 9, 10. Okay, and the 10th term is 115. If I wanted to know what my common difference is, I'm looking at, well, how many jumps did I make? How many hoops did I make to get from 190 to 115? So when you think about it, we did 190. Well, I'm going to do we did 190. We did 1, 2, 3, 4, 5 jumps. Okay, so when you think about it, we got from the 5th term, 190, we did 5 jumps, and each of our jumps is going to be our D, and we landed at 115. You can already tell just setting this up, D is going to be negative, isn't it? Hopefully I have my calculator. I already wrote it down. Good thinking, Miss Overby. All right, so We can already tell D is going to be negative, so we're going to subtract 190 from both sides. We get 5D is equal to negative 75, and we divide 5 on both sides, and we get D is negative 15, which makes sense, right? As we're moving down this table, if you're subtracting 15 each time, and you do that 5 times, you're going to end up at 115. So hooray, we found our D, and we know that to put an nth term definition together, we not only need our D, but we need our a sub 0. So we could continue this. We could say, all right, I'm going to, as I move down the table, I'm subtracting 15 each time, but as I move up the table, I'm adding 15. How many jumps, how many adding 15s am I going to do to get up to the 0th term? Let's see, 1, 2, 3, 4, 5. So to get to the 0th term, I have 190 plus 5 jumps worth 15 each, and that gives me 265. And that is my 0th term. All right, that's one way to look at it. That will always work. But wonder if it was bigger than 5 and 10. Maybe it was 5 and 50. That would be a real bummer. So let's go ahead and talk about what to do when they're bigger numbers and you can't use a table. You can actually set them up as points. Your 5th term is 190. And your 10th term is 115. So this is a second way to do it. We are already done. This is our answer. I'm just showing you a second way to go about this if the table isn't reasonable for the numbers that are given. So you can use those 2 points. You can find the slope, right? The slope's going to be the negative 75. The change, right? 115 minus 190 will give you the negative 75, and then the 10 minus 5 gives you the 5. So our slope is negative 15. The slope and the common difference are the same. So that's how you could do that. And then you could still, the second part will work because you set up your equation to find a sub 0. You say to yourself, okay, if this is the 5th term, so that's a sub 5, and I need 5 jumps, so that's where the 5 came from. And each jump as I'm moving up the table is worth 15. Then when we solve it, we get that. This method will work no matter what your numbers are. That's probably the most complicated thing we've done so far. And don't worry, you'll get plenty of practice with that on your homework. So let's go ahead and look at number 7. The 3rd and 4th terms of an arithmetic sequence are 11 and 15. Respectively, just looking at the time. What is the first term? So this is a very similar problem. So I would write this out. Okay, the 3rd term, a sub 3, is equal to 11, and the 4th term, a sub 4, is equal to 15. What can I tell already? I can tell that the jump to get from the 3rd term to the 4th term, right? We could look at a table, and if that's my 3rd term, and that's 11, and my 4th term is 15, we can tell that the jump was subtracting 4, right? So as we're moving down our table, we're subtracting 4, and that is going to be our D. So our D is going to be, okay, did I really do that? I did. 15 minus 11 is 4. But you know what? Here's to recovering after you make a mistake. We all do it, and there's no embarrassment. Just erase it and just keep moving. All right, so the common difference is 4, and then we're going to go ahead. They want my first term. This one, the numbers are great. I could just keep working backwards, right? As I move down the table, I'm adding 4, but as I move up the table, I'm subtracting 4, right? So if my 3rd term's 11, 11 minus 4 is going to give me that 7, right? And 7 minus 4 is going to give me 3. So my first term is 3. Is there another way to do it? Absolutely. I could take a sub 3 and minus, I'd have to go ahead and do how many jumps? Let's see, I'm losing my place here. So if I had a sub 3 is 11, right? And I'm going to subtract, because I'm jumping up, 2. And each of those 2 is worth 4, so I'm doing 11 minus 8. That also gives me the 3. That's another way to look at it. All right, so what's the first term? It is 3. All right, find the sum. Now we're talking about sums. And in class, we talked about, or we noticed some cool things. We noticed, wait a minute, if I went ahead and added the first and the last term, that gives me a 26. If I added the second and the second to the last term, that also gave me 26. And if I added the two remaining terms on the inside, that also gives me 26. So I could find my sum by saying 3 times 26. And that's where our formula for arithmetic sums, or arithmetic sum formula comes from. This 3 came from the fact that we had 6 terms, right? 1, 2, 3, 4, 5, 6. We're going to look at them in pairs, so we're dividing by 2. And the 26 came from adding the first term to the last term. So let's see, I'm going to actually write this out this way. So the first term was 3, and the last term was 23. And so if we look at it that way, I'm not going to go ahead and do the next one. In class, we had more time and we had more fun. But this leads to our sum formula. The sum, write it this way, the sum of n terms, and n stands for, in this case, we want to do the sum of 6 terms, but you knew any amount of terms that you want. The sum of n terms is equal to n, so the amount of terms you have, once again, that's why we use 6, divided by 2, times the sum of the first term plus the last term. And how do we write the last term? We write it as a sub n. So this is the second formula we're looking at. And this is our sum formula that works for when we want to add up the different terms in an arithmetic sequence. So we're going to go ahead and use that. Let's see, where's the next one? Because we did a lot of investigating in class, and we're not going to take that time on this video. All right, so here we go. They're giving us the beginning of a sequence, and they want to know if you extended the sequence out so that we'd have 50 terms, what would the sum be? Well, we certainly don't want to do that by hand. We don't want to extend it so that we have 50 terms. And so instead of doing that, we're going to use our sum formula, right? So the sum, we already know n is 50. And then that's great because we're good to go with the first part. And actually, we're good to go with the first term. So our first term is -6. So remember, our sum formula is n over 2 times the quantity a sub n, a sub 1 plus a sub n. And hopefully I did write it right over here. Yep, we're good. Okay, so how do I find out what the 50th term is? That's the big question. What is a sub 50? And so unfortunately, I shouldn't say unfortunately, because fortunately we have a shorter way to do it than the long way, which is to extend that sequence. The shorter way is to define it. And so we're going to define it, right? This is our, we're looking for the dn plus a sub 0. I can see as I'm moving up the sequence that we are going up by 4s, right? All right, so my d is 4, so I've got a sub n equals 4n. So then if I'm moving to the right on the sequence, I'm adding 4. If I move to the left, I'm subtracting 4, which means if that's my first, second, third, fourth terms, when I'm moving to the left and I subtract 4, I get that my 0th term is -10. I keep stepping on my cord. All right, so that's the definition. So I want to know, hey, what is the 50th term? Well, I just plug 50 in, I subtract, I multiply by 4, subtract 10, I get 190, and voila, I now know that my last term is 190. I put that in my calculator. Hopefully I wrote it down on my paper. Okay, and it is 4,600. So let's see, all of that, S sub 50 is equal to 4,600. Way faster than extending the sequence by hand and adding up each term. Amazing, right? So much better. All right, so let's look at 9. We're almost done. We have 2 more after this. Find the sum of the multiples of 5 between 1 and 300. If we want to think about this a little bit, I would write some things out. I've got students coming in 5 minutes, though, so let's think about this. If we were to write it out, we'd say we'd have 5 plus 10 plus 15 plus 20, and we would notice something. Every 10 numbers, we've got 2 multiples of 5. So when I look at the 300, I know how many 10s do I have in 300? There are 30 10s in 300, and each of those 10s have a multiple of 5. So I know that there are 60 multiples of 5. Okay, so we're adding 60 numbers. That was the first thing we needed to figure out. So we're adding 60 numbers. So we're good to go here. What's our first multiple of 5? Well, 5. And what's our last multiple of 5? 300. So it should have said inclusive. You know, we're including 300 in our multiples, but there we go, inclusive. And we're going to put this in the calculator, and we're going to get that all those multiples of 5 add up to 9,150. Wonderful. All right, let's look at this next one. Find the sum of the series. All right, this one's cool because we see that they gave us the first term, right? A sub 1 is negative 5. But the problem is we don't know what term 52 is. So we need to stop here and define this real quickly because the bell just rang. So we have a sub n equals dn plus a sub 0. So here we go. As we're moving to the right, we are adding 3. Yes, we're adding 3. So d is 3. And if we move to the left, we're subtracting 3, so a sub 0 is minus 8. Now we want to know, hey, what term is 52? So instead of a sub n, I'm going to actually put 52 in and then solve for n, right? I'll add 6 on both sides, divide by 3. So I can use this formula to find what term a number is. So 52 is my 20th term. And so now I know I'm taking the sum of 20 terms. And so I've got 20 divided by 2. My first term is negative 5. And my last term is 52. I'll put that all in my calculator, and I'll get that the sum of those 20 is 470. Okay, I have students walking in. We're going to go ahead and do one last one. Okay, find a sub 0 for the arithmetic sequence with a sub 1 equals 12 and a sub 4 equals 18. So I'm going to go ahead and do my shortcut and do my table. Can someone stop whistling? Thank you. All right, so I've got 2, 3, and my fourth term is 18. How did I get from 12? And I jump 2 places to get to 18. So I'm going to have that my D is 3, which is awesome. If my D is 3 as I'm moving down, I'm going up by 3. But to find my A sub 0, I'm going to be moving up by 3. I'm going to be subtracting as I'm moving up. And so 12 minus 3 is 9. So A sub 0 is 9. So I'm going to define this sequence as 3n plus 9. And now I am going to stop and come back. Okay, let's come back. And because I was rushing, I made a mistake. So second mistake for this video. But it's okay. I made 3 jumps, didn't I? I made 1, 2, 3 jumps. So I started at 12. I made 3 jumps. I ended up at 18. Now let's go ahead and solve it. We'll subtract 12 from both sides, divide by 3, so our D is 2. So as I'm moving down, I'm jumping by 2, and as I move up, I'm subtracting by 2. So 12 minus 2 is 10. So my sequence is going to be defined by a sub n equals 2n plus 10. That's right. And now it wants us to find the sum for the first 15 terms. So we're going to go ahead and say s sub 15 equals 15 over 2. My first term is 12. What's my last term? What's my 15th term? I've got to find out. I'm going to plug in 15 for n. And I get 30 plus 10 is 40. So my last term, my 15th term is 40. I put that all in the calculator and I get 390. And that is the sum of my first 15 terms. Thanks for joining me.
You're welcome.
What's